Well, folks, we're going to practice a little bit more today with the material we've been talking about with this folding paper and so forth. So we're going to take another look at that before I do make the homework assignment that I'm going to ask you to complete before the next class. So, or to give it a shot anyway. And so let's take a look. The sheet I would like you to get out now, which I already indicated to you before, is, of course, group worksheet number 3, okay? And it says, imagine starting with one piece of paper like the one this group worksheet is copied on, and building a stack of paper by doubling the number of sheets in the stack 50 times. Now, what I mean is you take that single sheet of paper and you fold it 50 times. That's the same concept as folding a single piece of paper 50 times, if it could be done. It says doubling the number of sheets in the stack 50 times. I didn't say that very well, but you know what I mean. So it's, if we double the number of sheets of paper we have in thickness 50 times, it would be the same thing as folding a huge piece of paper 50 times, if it could be done, and observing the number of layers of paper you'd have. Now, a single piece of paper is about 4/1000ths of an inch, or 0.1 millimeters thick. Better yet, though, we use one ream of paper is equal to 500 sheets of paper and has a height of 2 inches. Okay, so we discussed that already, so we're going to use that concept to help us here. First, agree on your intuitive estimate of how tall this final stack of paper will be. Which of the following comes closest to the height that you would guess? Any answer you give will be full credit. Would it be 10 feet tall, that stack of paper, if we folded a sheet of paper 50 times? Would it be the height of the building maybe you're in right now? The height of the Empire State Building? The height of Mount Everest? Or as high or higher than the distance to the moon? Well, let's take a look at this and see what we can do with this. All right? So, now, if we're going to fold the paper 50 times, if you recall from what we have just discussed, to determine the number of sheets of paper thick it would be found by doing what? Well, if you recall, you take 2 to the 50th power. It's exponential growth. So that's what I'm going to do here. I'm going to write over here 2 to the 50th power. That would be the number of sheets of paper I would have. Now, we want to know, how tall is that? Well, if it's going to be 2 to the 50th sheets, all right, we already know what? We already know that 2 to the 50th sheets of paper would be the thickness of the stack, okay, of the number of sheets. Now, how tall is that? Well, let's find out. Well, remember, for each of 250 sheets you have, or as it says here in this particular problem, for every 500 sheets you have, it shows a thickness of 2 inches. Well, we'll use 250 sheets is the same as 1 inch. So I'm going to put that down here. If I go 250 sheets per every 1 inch, okay, my answer would now be in inches, but that's an awfully small unit of measurement. So I think what we're going to do is maybe take it to feet. Well, let's see. Since inches is on top, I will put inches on the bottom, and for every 12 inches I have, it's the same as 1 foot, right? Okay, well, if it's 12 inches per every foot. My answer's now in feet. I don't know. Maybe we should put it in miles, just in case, okay? I mean, if we put it in feet, we'll find out it's a huge number of feet. So I know from experience that it's going to be pretty big. So why don't we do it right into miles to start with? So from what I'm showing you right now, or explaining to you right now, it's going to appear that the height of this stack of paper is going to be taller, definitely taller than Mount Everest. So it's going to be in miles probably. So let's give it a shot. Well, let's see. There's 5,280 feet, right, per every 1 mile. So let's figure out how many miles this bugger is, okay? All right, so I'm going to have to do 2 to the 50th, and then I'm going to have to divide it by 250, divide it by 12, and divide it by 5,280. So I think what I'm going to do is show you this on the calculator I have on the screen here. So let's do the computation. We can always come back. All right, here's my calculator. All right, I have to reshare the screen. So I have to stop the share we're on right now, and I have to share the screen with the calculator. So let's do that. So we'll hit that. Let me clear it. Okay, let me clear it here. All right, and so let's do the computation we talked about. 2 to the 50th. Now it's going to be huge, and it's going to overload this calculator. So I'm going to do 2, I'm going to do caret 50, enter. Now that's a big number, right? And I'm not too worried about what that number is because I'm going to be dividing it by all these other figures. So now that I have that answer, I'm going to hit divided by, okay? I'm going to divide it first by 250 because there's 250 sheets, all right? And I'm going to divide that answer, okay? Well, let's hit enter, and I'll divide that answer by 12, and I'll get that answer. And then I'll divide that by 5,280 feet in a mile. And look at this crazy number I'm getting. Holy cow. That looks like 71 million miles. 71,079,539 miles tall this stack of paper would be. That's incredible. Okay? Now wait a minute. That's almost to the sun, isn't it? The sun, on the average from the Earth, is 93 million miles. So this is 71 miles, certainly greater than the distance to the moon. That's a big number. So that's 710,079,539. Let me reshare back again. So let's stop this share here. We'll share back to our screen that we were on. And let's write our answer down. Okay, our answer is 71,079,539 miles. That is one big number. Now that's if you could fold a sheet of paper 50 times. And of course, you know we can't do that, but if we could, that's the answer we would get. All right, now with that in mind, calculate the height of the paper, use an approximate unit of measure, inches, feet, yards, meters, miles, whatever, etc. Well, we already did it. All right, so let's go to part 3. Answer question 1 again. You'll have to make sense of your calculation or to compare the result to the choices in question 1. Show the steps. We already did that, so I'm not going to worry too much about that, okay? So that is obviously a very huge number. Now let's do something a little bit more reasonable maybe and a little easier. And of course it's on the back of the sheet. How many times would you have to fold a large piece of paper to reach or surpass the height of a 38-foot flagpole? Well, why don't we convert the 38 feet into how many sheets of paper thick you would have to be to reach that height of 38 feet. And then we can figure out how many folds we might need to make it happen, right? So let's take a look at that. All right, so here we go. We're going to take 38 feet We're going to change 38 feet into what next? Probably inches, right? For every 1 foot, there are 12 inches. All right. Now, how do we get this into sheets of paper? Well, remember, for every 1 inch, okay, of thickness I would have, it's the same as 250 sheets, right? So for every inch of height I have, I need 250 sheets to be able to be equal to that. So if we do this computation, we simply do, I'll do it back here, 38, whoop, come on machine, 38 times 12 times 250, and the answer I get to that is 114,000 sheets of paper. Now, 114,000 sheets of paper, all right, how many times would I have to fold a piece of paper? It would have to be a huge piece of paper also, but how many times would I have to fold a piece of paper to get it to either equal 114,000 sheets of paper in thickness, or at least beat it, okay? So my question I'm asking is, 2 to what power is going to be greater than or equal to 114,000 sheets? Now again, you remember how we do this? We do it by trial and error, baby. Trial and error. All right, so here we go. We've got to T&E this, so let me get back to the calculator. So we're trying to beat that figure. Sorry about this switching back and forth, but I got to stop the share so that we can show this on the calculator for you to see it. What do you want to try to start with? Okay, want to try 2 to the, I don't know, 15th, see what that gives us, see if it's too big, too small. So let's clear all this out, and let's go 2 caret 15, enter. Oh, that's 32,768 sheets. That's not very close to 114,000, right? So we got to go higher. Shall we try 2 to the 17th and see what it gives us? So let's do that. We'll do 2 caret 17, enter. Ooh, that's 131,072 sheets of paper. So that is a little too big, right? It's, well, maybe not. Yeah, maybe that's what we're looking for. Because if we use 2 to the 16th, I think will be too small. So let's try 2 to the 16th. 2 caret 16. Notice we're using the trial and error method. T&E, baby. Enter. All right, that's 65,536. So 2 to the 16th is definitely too small. 2 to the 17th is a little bit too big, but it would take what? 17 folds for us to be able to beat the height, okay, of a 38-foot flagpole. Imagine that, right? Imagine that. So as we can see, we would need 17 folds, okay, to just beat our 114,000 sheets of paper. A large sheet of paper has a thickness of 4,096 pages. How many times must the piece of paper have been folded to reach the thickness or the height that we're looking for of 4,096? So you can see I've set the problem up already, and what we had to do is say to ourselves, what power of 2 would be greater than or equal to 4,096? Well, it turns out that 12 folds are exactly 4,096. If you put into your calculator 2 caret 12, you get 4,096. And so we need 12 folds. And what is the approximate height in inches? Well, if I take the 4,096 sheets and I convert that into inches, all right, I simply do it by the conversion I have shown you on the screen right here. And the approximate height there would be 4,096 divided by 250, or about 16 inches, okay? And if we want to know what the approximate height is of that in feet, you would divide again by 12, and you would find it's a little more than a foot, maybe 1.5 feet, okay? So we won't worry too much about finishing this problem. You've got the idea. Okay, let's go on. Okay, we've already done that problem. I want to explain to you the homework problem I'm going to ask you to try before we get together tomorrow. What I would like you to do is to try homework, this homework sheet after group work 3, it's called. Let me tell you how this problem came to be. I was in Wegmans one night on a Sunday night, and my wife asked me to pick up a case of water bottles, okay? So I looked and found the case, and I picked it up to put it in the cart, and I go, holy crap, is this heavy, all right? And I thought to myself, man, I could probably make a cool math problem out of this. So I wonder if I can find out the weight of this 35 pack that's wrapped in plastic. So I went around all over the store looking for a scale that I could use to weigh this thing. And they couldn't do it up at the counter where you checkout counter. So I went back to the back of the store, and I ran into somebody from the meat market, and they said they had a scale that would weigh it. So I took it back in behind the meat market, and we weighed it, and it was 41 pounds. I couldn't believe it. Now, the water bottles inside measure 7.5 inches, 7.5 inches, as you can see in my diagram here. So I decided to make up a math problem about this. So here we go. This is how it works, or how it goes. And I'm going to ask you to try this series of math problems here, and one that's on the back of the sheet. All right, so if the cases that we have of water bottles, how many would you have to stack on top of each other to reach the height of a 6'3" female high school basketball player? Now, once you've determined that, I would like to know which would weigh more, the female basketball player or the cases, or 35 packs, equal to her height, and explain your answer. Now, some of you are not from this area and you haven't been downtown, but if you have been downtown, you will notice that the largest building downtown stands near the waterfront, and it used to be called the HSBC Tower. Actually, when it was built in the early 1970s, it was called the Marine Midland Tower, but then HSBC Bank took over Marine Midland. Well, since HSBC Bank has gotten out of the local banking industry, they gave up the building and now it's named something else, and I'm not even sure what the name is. But that building, I would like to know if it is 846.4 cases tall of these water bottles, what is its height in feet? And how many folds of a great big sheet of paper would be required for you to just surpass its height? Finally, which pickup truck bed, you know what a pickup truck bed is, it's the back end of a pickup truck, which bed would contain more weight? One filled with 32 cases of these 35 packs of water bottles from Wegmans, or one filled with 82 16-pound bowling balls? Okay, a little different problem, right? Okay, now there is a problem on the second page of the sheet, or the back of the sheet, I usually call it. All right, and I would like to just briefly go through that with you. All right, Billy can fold a huge piece of paper in half on the average every 30 seconds. He has been promised to be paid by his rich friends $5 per every 1-inch layer of sheets of paper he compiles in 8 minutes worth of folding. Will Billy receive or be paid more than $1,000 for having performed this stunt for his friends? Show your mathematical reasoning for determining your answer. Remember that 250 sheets of paper have a thickness of 1 inch. So before we meet tomorrow, I would please like you to finish this little bit weird and different math problem, and we will go over that first thing in our next class. Well, I hope you all take care, and I look forward to seeing you very soon, like as in tomorrow, right? So take care, and we'll talk soon.